What's up? Hey guys, welcome back to AlgoYogi. We are still doing two-pointer series. Next problem in the list is bag of tokens. Let's go to the problem on LeetCode. So it says you start with an initial power of the variable power, an initial score of 0, and a bag of tokens, which is an array, basically integer array, where token I represent basically the value of the token. Your goal is to maximize the total score. That's what we're gonna return at the end of the day. And here we need to play this little game, if I just tell you in my own words. And then there are like basically two main steps to this game. One is face up, another is face down. So it's like if your current power, which is a variable, which is an integer that represents the current power you have, and you can use your power to basically face up. So if you have your current power at least more than the value of a token, then you can face up the token. That will basically you will lose that much of the power, but you will gain one score, right? But at the end of the day, that's what you want to do, because you want to maximize your score, right? But then what about face down? Face down will basically give you that much power, right? If you face down some token, then it gives you that much power, but it takes away one score. That's it. That's the entire game. It sounds very simple, I guess. Like initially, when you read this description, it might be confusing, but if you go through it, like take it as like just two steps: face up, face down. Face up takes away power, gives you a score. Face down gives you power but takes away the score. At the end of the day, what we want to do is we want to face up as many tokens as we can, so that we have the most score. But sometime we might want to face down some some tokens, so that we get that much power. We could use that power to basically face up many tokens, which will give us more score. Let's go to iPad and try to understand what we basically mean. So what I meant is we are given tokens. So this is an array, integer array, and then we are given power. What we want to return is score. This is what we want to return. We want to return score. We can use power to basically face up my token, which will give me +1 score. But you can only face up. You can only face up if power is greater than or equal to the token I. Tok ith. This is what I mean. So here this is value 100. It's not greater than 50, right? It's not greater than 50, and you don't even have a score. Right now the score is 0. Right now the score is 0. Okay, so with a 0 score, you can't face down any token, so you're not going to gain any power, right? So in this case, I guess the score would remain 0. We can't really do anything, and we'll just return 0. Let's consider another example. Let me just remove, take back all of this. Let's keep the power 50, and let's have this another array where I have this. We can say like I have 50, and then I have let's say another 50, and then I have 100. Now I again start my score with 0, and my power is still 50. But now what can I do is, if you see over here at the tokens, the token is basically less than or equal to my power. So I'll use that power to basically increase my score. So now my score is 1. My score is 1. But I lose that power. So 50 minus 50. Now my power is 0. My power is 0. Okay. So what do I do now? Do I just return 1? Do I just return 1? But we know, actually no. Because right now our purpose is to maximize score. Is this the maximum score we can gain by face up, face down, as many tokens as we can? Actually, no. If you see, we could use this. We could use this score to basically face down 100, which will give me. So I decrement my score by 1, and I face down this 100, which gives me its value as power. So now I have 100 power, right? I have 100 power, and what will I do now is I will face up these two utilizing this 100, 50, 50, and which will basically increment my score twice. This will give me the score of 2, which is more than the score of 1. That's the entire thing. So I think what we really want to do is sort our tokens array, so that we will check if my power is greater than my score in the beginning. What I want to do is, like, I want to face up as many tokens as I can, which are smaller in value, so I can go from the beginning. Like, if I have a sorted tokens, that I'll start facing up these tokens from the beginning and add those to my score. And if I run out of this power, I would just go to the last the largest token and utilize my score. If my score is greater than 0, then I'll use that score, and I'll just face down this thing, the largest token, use that as my power, and to again face up more tokens so that I have more score. And at the end of the day, I want to have more score, not more power, or just more score, so that I want to do as many tokens face up as I can. Alright, so let's go to LeetCode. First thing first, we're going to be sorting the tokens, and then we'll have 2 pointers to basically pointing the beginning and the end of the tokens. And then we check if my power is basically greater than the current token value. Okay, so let's just think what we're going to do here. We're going to have a result, which will be basically the maximum score we could have owned at one point, and then we're going to have basically the score is initially 0. So remember, result is just what we're going to return. Score is basically the current score, but result is the maximum score at any point when we were doing this face up, face down, and we could do it as many times as we can. Okay, so now we're gonna have like 2 pointers, so left and right. Left will be pointing to 0, and right will be length tokens, and just make it valid. Okay, so what we want to do is, while left is less than right, or maybe we could just say equal, then I want to check if my power is basically less than or equals to tokens left pointer, right? Tokens left pointer. If that is the case, what do I want to do? I want to increment my score immediately. Okay, I will increment my score, but what else? I will decrement my power. I'm using that much power to gain one score, right? Gain one score. So I'll decrement my power. Okay, that's one thing. Now, what else? This is one scenario. This is one scenario, but I have increased my score. But what I actually also want to do is I want to update my result with max of result and score. Okay, now is the interesting point where if I run out of power, then I might want to use one of my score to basically gain the power from the end. I'll face down the last token. So what I'll do is, okay, let me make it look a little nicer here. Okay, I always forget it, I don't know. So LF, my score is greater than 0. If my score is greater than 0, then I want to also, that's one thing we forgot, we want to increment my left pointer. And if my score is greater than 0, so I'll basically increment my power by what? The tokens right and right -1. Okay, I gain that much power, and in the end we can just finally return result, not the score, result, because the result is what score must have been at one point when it was maximum. That's what we were trying to maximize. We would stop playing at that point. Although in real game it doesn't happen like that. You whatever you have in the end is what you take home. But in this case, we'll stop. We would know what was the maximum point where we had the maximum score, so we just walk out. So I think that is it. Let's zoom out and run it. But you know what's better is, like, we can actually just go over this again. So we have result, we have score, left and right pointers. Then we want to just check if left is less than or equal to r. Then one of these things will happen, right? So score will be incremented if we have power, we have enough. Well, no, this is not what we want. We want to have, like, power is greater than or equals to, otherwise this. So let's run it on examples. Did we forget anything? Okay, well, this, if maybe they're saying, what if they were equal and none of these conditions matched? I think this is what we need to have. And oh my god, did I submit it without? Okay.